All right, I see that more people joined. Again, hello everyone. I'm still Max and I'm from SecurityGen Marketing. Pumped up to welcome you all to our webinar featuring GTP Vulnerabilities. It's a very insightful session about the GTP security and the codes which poses the concern for 5G and LTE networks. Our speakers today are Pavel Novikov, the head of Telecom Security Research. And we have also Kirill Buzankov, who is our product manager. We are about to dive into the GTP network security and get ready for a really mind-blowing session. We are really thrilled to have you here. If you have any questions, glitches with the video or sound, shoot me a message. We are here to ensure a smooth webinar ride. Let's all make this session both informative and entertaining. Don't be shy. Feel free to speak up, ask your questions, and hang tight. We are kicking off. I give the floor to Pavel and Kirill. Good luck. We are beginning. Thank you.
Okay, hello everyone. Hope you hear me and hope you see me. Today we are talking about GTP vulnerabilities, and the webinar is called GTP Vulnerabilities: a cause for concern in 5G and LTE network. So who we are? I am Pavel Novikov. I'm 10 years in telecom security. I am co-author of GSMA FS20 GPRS Tunneling Protocol security document by GSMA. I'm head of telecom security research in SecurityGen. I'm focusing on telecom vulnerabilities in RAN, VoLTE, voice over Wi-Fi, GTP, diameter, and other stuff in 5G in mobile network. And I'm conducting telecom security assessments for mobile operators for many years. Kirill?
Yeah, thanks, Pavel. So, well, luckily, I'm the same 10 years in telecom security. So I'm a product manager in SecurityGen, right? And I'm exploring the telco threats, have been exploring telco threats and vulnerabilities starting from SS7 up to 5G now, right? All the technologies, mobile cores, and we are growing solution for protection of our mobile core network assets, as well as providing visibility of the network security posture. Up to you, Pavel. Thanks.
Okay. And first of all, we need to understand what is GTP. Please don't mess it with chat GPT, the same letters, different meaning. So it is GTP, not GPT. It's a GPRS Tunneling Protocol. It's a group of IP-based communication protocols used to carry general packet radio service, GPRS. Please don't think that it is something very old and not used in modern networks, because it's used for GSM, for UMTS, for 3G, 4G, and even for 5G networks. Here on the slide, you can see that GTP, it is not the one protocol, it's a group. And there is, for example, GTPC protocol, which is control plane. You can see some 3GPP specification related to this protocol. Also, we have separated GTPU protocol. It's a different one. So while control plane is responsible for establish connection, close connection, update connection, and so on, GTPU protocol responsible for carrying your data to the internet. For example, when you using your mobile phone and connect to internet and trying to use something, for example, watching YouTube. So your traffic passing encapsulated in GTPU tunnel, in GTPU protocol, and passing to the internet over mobile operator's core. There is also a third one, it's GTP prime protocol. It's separate protocol, which is basically adoption of GTP protocol to transfer charging data records from some nodes of mobile network to another nodes of mobile network. It may be used in some network, it may be not used in some networks. So GTP prime is not obligatory, but when we are talking about GTPC and GTPU, it is always in each mobile network. So when we understand what is GTP protocol is, we need to understand where is GTP protocol is in mobile network. And on the picture, you can see that it's simplified structure of mobile network without some signaling pieces. But here you can see that there are quite multiple number of interfaces which have GTP protocol inside. For example, the main interface is S5 interface between SGW and PGW. There is GTPC and GTPU, but also instead of that, there is, for example, S11 interface between SGW and MME. There is S10 interface between different MMEs. So all these interfaces carrying GTPC protocol. And again, there is some GTPU between base station and SGW. There are also some other interfaces which is not present on this picture, like S4, S3, but it is not main one, so we will not go deep in that. Now we understand where this protocol is used, so let's look on what this GTP protocol is. So you can see that it uses usual IP structure. So GTP protocol is using UDP protocol as transport layer. And as you know, UDP protocol doesn't have any verification if packets appears, if packet didn't mess between each other. So that's why all this stuff should be done via GTP protocol itself. But if you're looking on structure of GTP protocol, it's quite easy. It have GTP header, and it have list of information elements. Depending on the message type of GTP message, so there could be a lot of information elements or small number information elements, but it doesn't matter. You just need to understand that it is quite simple and clear protocol. On the right side, you can see some capture from Wireshark. So how this protocol looks like, and here we can create. We have create session request message. So this message is made to create new tunnel, and you can see that there is some important IDs like IMSI, and it's in clear text. MSISDN, which is mobile number of subscriber, so it's also in clear text. IMEI, so it's identity of mobile phone, so it's also there. Also, there are some location information, IP addresses, and a lot of different stuff. And all this, it's quite in simple and not encrypted manner here. So due to that, let's talk about GTP security, why it's so important and why we raise these questions right now. First of all, it's widespread because every mobile network in the world should have GTP protocol. Otherwise, it will not be able to provide data services for their subscribers. GTP protocol is transparent, and so I mean there is no any encryption and any built-in security mechanism, because this protocol was made dozens of years ago when mobile networks was like isolated from external world, and there was like thinking that mobile networks communicate between each other, so they are all friends, and there should not be any intruders there. So, and due to roaming connection, so all the operators connected between each other via GTP protocol. Due to that, there is some vulnerabilities and threats, for example, fraud, interceptions, denial of service, etc. So there is quite a number of different threats there. I mentioned roaming, and I will try to explain how it works, because here on the top you can see some very simplified structure of mobile network operator, network number 1, and we have user from this network who connected to another network, to the second network. And if we have a look how it works, so if the subscriber from first network moves to another country connected to another mobile operator, so his data will pass over this way. So to go to the internet, data will go over base station of visited network, over SGW of visited network, and then via GRX network, which used to connect all the operators involved between each other. So this data will pass to home operator, and you will get to the internet via home PGW. And the same story for second subscriber who moved to the first network, so he will get internet via this way. Due to that, you can see that these nodes, which is SGW and PGW, they are always connected to GRX network. And even if you are in home network and using mobile data in home network, and you don't use any roaming network for your communication, your data will pass over this way. But still, attacker can be in GRX network, and he can influence to your connection, sending packets directly to PGW or directly to SGW, and affect your tunnel. And in this case, it may be interruption, interception. So a lot of possibilities for attacker. And the main problem here is that mobile network doesn't have any options to verify. So it sounds logical that when you are at home network, so your tunnel is here, and nothing should come from here for this subscriber. So it looks very logical how you can secure your connection. But the problem is current equipment doesn't have such techniques or built-in mechanism which may distinguish that. So SGW and PGW, they just acting using GTP tunnel A, and they don't care about who is the originator of this traffic. So this is a main problem of this roaming attack vector. Yes, I am briefly explaining what's the problem and what the GTP protocol is, and now I can go to results which we have. So as we are doing telecom security assessments for mobile operators, we have information about security of these mobile operators. So due to last year, we tested, so we had more than 150 telecom security assessments in 39 mobile operators in the world. It covers about 24 countries, and the regions was SEA, MEA, and LATAM countries. So we use, in our methodology, we use specific tool. It's our tool called ACE. It's Artificial Cybersecurity Expert. So it's this tool allows us to check security of mobile network without any influence of working of this network. So we just touching some tested SIM cards, and so we getting some results from the network, we getting report and providing it to our customers to highlight them problems and to make them to help them to mitigate that. So we use some attack scenarios like data interception via create PDB context request message. We have fraud via create session request. We have impersonation, data disclosure, network denial service, subscriber denial service. I will go deeper in each of them. What is that? So we have question, what is GRX? GRX, it's global roaming exchange network. So this network made to connect all the operators in the world between each other, and then they can exchange some data between each other. So this is GRX network. Okay, let's go next. So after our security assessments and taking into account result of these security assessments, we have statistics that about 15% of tested networks have critically low level of protection. On such networks, almost all cases, test cases and attack threats was successful. Another 8% of the networks, they have low level of protection. So most of test cases were successful, but not all of them. More than half of all networks, specifically about 54%, have a medium level of security. So some problem is there, some test cases is working, some is not working. So, but still, malicious actors can do significant problems for these operators. And only 23% of mobile network have high level of security. In such networks, only few test cases was successful. So it's kind of a good result nowadays. So now let's go to threats and impact. So in 85% of the networks, so these networks are vulnerable to targeted denial of service attacks via different techniques. First technique, for example, it's fake session, creation of fake session on behalf of the subscriber. So in 85% of the networks, it is possible to create. So when we're creating this fake tunnel, real subscriber will be disconnected for some period of time, and so denial of service will be affected. So the subscriber will be affected by denial of service. Also, we can eliminate not only we, but attackers can change PGW node and redirect subscriber traffic to other node, probably to malefactor node. And in this case, his tunnel still there, but the traffic is not coming to the subscriber. And another option is deletion of subscribers session. So it's very simple attack. So we just send in a request to delete subscriber session, and this session will be closed. So this leads to subscriber denial of service. About 71% of the networks are vulnerable to information disclosure attacks where, for example, there is a way to obtain TID. TID is unique identity of tunnel. So this TID needs to carry out other attacks. So by itself, it is not something critical, but this TID is required to carry out other attacks. Also, it is possible to obtain IMEI, radio encryption keys. For example, it is possible to update radio encryption key, and the malefactor can deploy his own IMSI catcher and connect victim subscriber to this IMSI catcher via this attack. Also, some internal IP addresses can be obtained by a malefactor as well. Another kind of attack is data interception. In 69% of the networks, they are vulnerable to this interception. The intruder can change the actual nodes which process user traffic. So all incoming traffic will be sent to intruder, and he will do something with that. Another kind of attack is fraud. 62% of the networks are vulnerable to this technique. And the idea of fraud is establish connection on behalf of non-existent subscriber. And in this case, mobile operator will not be able to charge someone based on this amount of data which was spent. So mobile network operator will lose his money on that. And about 46% of the networks are vulnerable to network denial service. Network denial service can be achieved by sending some big number of requests to open new connections. So each connection provide IP address to users. So each connection should have its own IP address, and as a result, an intruder can exhaust all whole DHCP server pool or even GTP tunnels pool. So as you can see, so almost each thread is there in almost 0.5% of mobile network. So so what customers and you may raise question like what's the protection measures for this? And I can say that there is several ways how to protect from GTP attacks. First of all, it's filtering incoming traffic based on IP address of roaming partners. Second, it's implementing GSMA recommendation security measures. And third is combination of both approach. Let me explain a bit deeper each of them. So when so first is like when mobile network operator has like some usual IP firewall which can block by IP address, and so they may protect from some strangers in GRX network. So only trusted partners will have access to their infrastructure. But there is some points of concern and security weaknesses because attacker may gain access to the trusted MNO. And sometimes partners may lease their IP ranges or even parts of their infrastructures for third parties, because now it's business. So, and if there is some requests from markets, so some companies may lease some access or so on. So it's still possible. So this the way of protection is not protecting basically, because it's protecting only from strangers in GRX network, but it is, I would say, it is not real protection. Second one is based on GSMA FS20 GTP security recommendation. And this is quite good document which contains some information about which attacks are possible in GRX network, how to build secure network, and so on. And even it has some requirements for GTP firewall. So there are some specific rules which should be applicable for GTP firewall. GTP firewall is not usual firewall because if you remember, I mentioned that GTP is encapsulated in UDP, And usual IP firewall can act only on UDP layer, because GTP layer will be some kind of application level for the for usual firewall. And usually IT firewall are not able to verify any information based on GTP protocol. So we need some specific GTP firewall, which will have some specific rules and specific options to parse this protocol and to make decision based on information in this protocol. Instead of GTP firewall, there is also recommendation to implement monitoring, because without monitoring, you will not able to see if, even if you deploy GTP firewall, you will not be able to see if you still have problems, because we have some examples when our customers, they buy GTP firewall and they say us that, oh, all your attacks will not pass over our GTP firewall because we have it. But reality is that we still can act as a malefactor without any issues. We even doesn't notice that, so we didn't notice that there is something in their network which should protect their network. So without monitoring, there is a possibility that when you install firewall, there will be no any rules out of the box, and it will be transparent like water. So every packet in GTP may pass over that. So, but you don't know about that because you don't have any monitoring and you don't have any information what going inside your network. And so third option how you might protect your network is combination of these two ways of protect. Well, it may provide the highest level of security. But if we go to current real security measures, which we see in mobile networks, so we can state that only 8% of the networks, they have some IP filtering of roaming partners. As I told, it may not be a good protection, because if your partner leases his infrastructure or IP addresses to someone else, so it's still vulnerable. About 15% of mobile operators, they have some security measures which is not directly connected to the security. So due to configuration of their network, some attacks may not pass into their network, but it is not security measures, it's just because of configuration of the network. And so 77% of mobile networks, they don't have any security measures in mobile network. So as you can see from this graph, no any operators implemented GTP protection based on GSMA recommendation with GTP firewall. So we have experience, as I told, that some customers saying that they already have GTP firewall, but sometimes it's still not working. So that's the result of our investigation related to GTP security assessments. I have also one question. So if GTP tunnels are not encrypted, then how is the user data secured? So I can say that user data is not secured by GTP protocol. So, but when you're serving some internet, so for example, some web page, so usually for now, most of the internet using secure version of protocols like HTTPS. So your communication will be secured on application level on HTTPS. So I explained the problems in mobile network and about real security measures, which we can see in mobile networks. And now I think it is time to talk about our solution for that. And I'm passing my words to Kirill.
Thanks, Pavel. So let me share my screen.
While Kirill is sharing his screen, I would like to thank everyone who is addressing questions in the chat. So we are all making this session interactive and insightful. Kirill,
Yeah,
the
thanks,
floor is
Max.
yours.
So, of course, I mean, what the Pavel has explained, right? So we're doing that multiple security assessment during the year, and regarding GTP, of course, we have something to suggest to the market. And if you actually observe the threats, right, that exist on the GTP firewall, basically the same threats that Pavel just explained recently, right? They just from the first glance, they could be addressable by the GTP firewall. So if we're talking about some kind of subscriber denial of service or the network denial of service, so it's about the, for example, generating of excessive volumes of messages, right, to cause some service disruption, or even worse, when this kind of flow of let's say signaling messages, packets is coming to disrupt the network element disruption to provide the outage of the whole network segment, right? Or it can be an information disclosure, right? So obtaining some information, for example, TIDs, IMI, encryption keys, or internal IP addresses that makes it possible for the future attacks to proceed, right? So disclosure of information helps to proceed a malfactor further. Of course, the fraud, right? So attackers can use some data, right? So they can exploit the data tunnels of existing subscribers, or just, let's say, generate data tunnels based on, let's say, unexistent subscribers to use, for example, the internet for free. And that caused damages for the network. And eavesdropping, of course, interception and snooping of the traffic, of GTP traffic, for gaining valuable and confidential information is also cost much. So, and these all threats, they can be covered by the GTP firewall. So speaking about our SecurityGen GTPC protection suite, right? Let's observe like what we can suggest exactly. So our portfolio, right, for GTPC is actually consists of the two basic models. Like this is the TSG firewall and TSG IDS. So the firewall, I think, which is most understandable to the audience, right? It provides like complete protection of GTP against GTP attacks on the control plane, right? So it protects from suspicious traffic from unverified sources, attacks about interception, denial of service, or information disclosure, fraud, etc. So the firewall is fully compatible with FS20, and it supports all the GSMA categories starting from 1 up to 3. So, and another thing that we also have the GTP IDS model that takes a separate feed from the passive flow of the traffic, just to analyze and make sure that no, let's say, no part of the flow is actually missing the GTP firewall, because once, let's say, the piece of the traffic actually goes beyond the firewall, the TSG IDS will signal about that and will detect the alarm regarding the attack has happened. The firewall didn't do its work well. So speaking about these two models and the HLR, right? So when we speak about subscriber location data on the GTP protocol, it's quite a subject that has to consider other protocols for the correct location information, because the location information that can be gathered on the GTPC protocol is not that valuable because it can be easily hacked. So basically, in order to withstand especially GSMA category 3 attacks, the firewall should have the knowledge about the subscriber location information from the other protocols like Diameter or SS7, right? That's why we introduced the interaction from the GTP firewall with the HLR HSS, so that when the category 3 message comes in, either it modify bureau request, create session, or update PDP context, doesn't matter. It actually will communicate with the home location register. So it's a database of home subscribers that can provide information about subscriber real location and can correlate this information with the message, with the source of the potentially malicious request, right? And when this correlation is being done, so that the system can analyze like if this is a legitimate request or this is some kind of the attack attempt, right, happening because the subscriber is actually roaming right now in another network. So going further, speaking about, let's say, GTPC firewall network integration, right? So this is the usual scheme you can see. So usually it's placed between edge routers, and GTPC firewall is being placed between those. So basically, all the requests that are being received by the edge router 1, they go through GTPC firewall, and then they are sent to another router. In this, and after that, of course, they are delivered to the end customer equipment. Would it be SGV, PGV, or whatever, GGSN? But of course, in some networks, there might be a situation when there is only one router that is serving all the GTP network, right? In this case, of course, the loopback mode is also available, so that the GTPC firewall, the pair of redundant firewall, they're going to be processing the traffic that is arriving from the IPX segment and returning back to the same router, right, on another interface, but only the allowed traffic. So this basically like explains the way of possible integration. If we speak about the GTPC firewall features, right? So first of all, of course, the GTPC firewall is designed to be GSMA FS20 compliant, and FS20 is basically talking about GTPC recommendations by GSMA, right? Support of GSMA category 1, 2, 3. The versions of GTP protocol that we take that were explained by Pavel, right? GTP from version 0 to version 2. Session management. When we talk about session management for monitoring and tracking, right? It's quite valuable to actually gather all the subscriber sessions, because there are some messages on GTPC level that do not contain any subscriber location information apart from the session identifier. So based on that session, you have to identify which kind of subscriber this session is related to. So for example, if you need to get subscriber location, like based on category 3, you need to know for which subscriber you need to request this kind of information. And this is crucial. Cross-protocol subscriber location validation. So that basically underlines the same approach, as you cannot really trust the location information that might be contained in GTP messages, right? You need to be ready to confirm that the location information is actually confirmed by SS7 on Diameter. APIs. So RESTful APIs that are available for integration with third-party systems. It's not only about the performance management metrics, right? Because some systems are eager to take this, like the RDD utilization, memory, etc. But it's also regarding the SIM system. because some SOC departments are eager to see their information in their own combined systems. So SIM integration, performance management integration, that goes just out of the box. Report generations or on-demand and schedule base. So you can not only, let's say, generate reports whenever you log in and press the buttons, you can also, let's say, schedule this kind of reporting when you feel comfortable for that. So basically, like if you want to receive the statistics about your GTP performance, GTP attacks happening in your networks, GTP attack attempts, or GTP firewall events, you can do that using the tool. And the validation of source node based on GRX database. So that basically one of the features, one of the approaches Pavel underlined, like how you can approach the GTPC protocol network security. Speaking about benefits and value, right? So when we talk about enhanced protection, so GTP firewall, it significantly reduces, right, the risk of cyber attacks, and therefore it of course ensures customer data protection. When we speak about comprehensive security, we know that GTPC is a protocol that is a part of the world packet core. So even if we think that, let's say, SS7, 2G or 3G will disappear in some period of time, we cannot think the same about GTP because it is a part of VPC, and as a first step of protecting, let's say, the 5G network ecosphere, we should be worried about GTP security. And of course, the platform itself, it allows to protect the mobile core network assets starting from 2G to 5G. When we talk about operational efficiency, right? So again, by implementing some traffic policies and managing them, we ensure that the operation is not suffering, right? So streamline user experience. If any of our customers are accustomed to our portfolio, right, to our products, in this case, they will understand how simple it is, let's say, to retake the knowledge they got from the, for example, working with diameter firewall or SS7 IDS, whatever, because they will have the same interface, the same smooth work and user experience. Simple integration, of course, having multiple ways of integration into the network, right? Either it is loopback or is directly inserted between the switches, right? So it provides the options for the end customer to provide the integration as smooth as possible. Regarding the future-proofed, we already discussed, right? So the GTP will stay as a part of the EPC core. So that's why it's, of course, very important. Regarding the compliance, so of course, having the GTP protection suite helps you to do the compliance, either it be, let's say, some governmental regulations or some, let's say, industry security standards, either like ENISA or GSMA, etc. So that will help a lot. So right now, I would suggest to just have it the GTPC next generation firewall quick glance into the product, and then we can return back to the questions. So let me reshare, please.
Again, while Kirill is resharing the screen, I want to thank everyone for asking questions. We are making this session very informative. Thank you all, and don't hesitate to raise anything you are interested in. The replies are in the chat. Some of them will be vocally announced. Thank you.
Okay, so I hope you can see my screen.
Yes, everything is okay.
All right, so you still can see it, right?
Yeah.
Okay, so speaking about, let's say, our product, right? We are now on the main screen of Telecom Security Guard, which is a platform for several generations of the mobile core networks, right? And today our focus is actually falling on GTP. So when we are on the main screen, right? So we are actually observing the attacks dashboards, and the one you see on the right, on the upper side, right, is the heat map. So this is the heat map that actually represents the source countries or target countries attackers, right? And here we cannot see source countries because this is probably the IP addresses that is unknown, because this is a local host, and of course this is all generated data, and it's not real one, right? Of course, but let's say, speaking about the data that's being here generated, so we can notice, apart from the attack types that are happening into this, let's say, GTP network, right? We can observe the targets. So let's just focus. Okay, we have some Sweden target. We can click on this. We can put a filter that is equal to the IMSI identifier and apply this. And let's look what's happened to this specific IMSI identifier of the subscriber. Right now, we can see that only 4 kind of attack types were happened to this IMSI identifier. From the sources, of course, you probably all know that this is a local host, but again, this is generated data, right? And you can see here the statistics regarding the destination, target, sources, and it's all been identified based on the prefixes that the TSG Telecom Security Guard system gets from the IR21 documents and other sources of information that helps to maintain up-to-date database prefixes, right? Potential impacts, severity levels, and the GSMA categories distribution. So what is interesting from that, right? So apart from the attack dashboards, like we can switch to the attacks, right? And that's the place where we can see the detailed information about the events that were happening. Specifically to this filter, right? And we have a filter that targets IP address that is related to Sweden. And what we can do is just click on the expansion of any kind of attacks, right? Expand the details and explore the information that how the packet was formed, etc. So once we understand that, for example, this is a bad source that we would like to block, right? So we can click on it. We can make several filters. We can add it to whitelist, or we can create a firewall rule. So right from the IDS system, we can create a firewall rule that will prevent some further integration, further disruption of the network, right? So there is the firewall group. You may have the group of firewalls to be applied, right? The description, type, whatever you want, the category. So the category, if you know the category, you will choose the one, or if it's category 0, you want to invent some custom block list, for example. The action, you choose the block, and it already suggests you the source IP address to be blocked. And of course, you can extend this rule with some other operands and create some other features, some other aspects of the rules, right? So speaking about the rules, of course, they are stored in the firewall ACL, right? I think I lost it. Yeah. So here, if we go to the firewall rules, we focus today on GTP. Yeah, we have this set of rules, right? And it's going to be added to specifically this set of rules. You can edit, modify different kind of rules, right? With the syntax provided and with the syntax help. And speaking about the visualization of all of this, so you'll go to the firewall dashboard, and you'll notice that for this kind of IMSI that we recently chose, right, there is only one kind of message type, attacks, right, update PDP context request, and it was in allowed state mode because you can see it green, not the red one, and that is it. So basically, if you want to go dive into the details, you will go to the firewall events. You can see only 8 events happening. And of course, you can again expand the message, expand the event, and explore what kind of information has been used to craft this kind of message. So that was the very quick, let's say, lead intro into our product. I think right now, as we are kind of running out of time, I'll just end the demonstration, and we are eager to answer questions. So let me stop the sharing and
yeah, thank you, Kirill. Thank you, Pavel. This is again Max speaking. Thanks everyone for asking so many questions in the chat box. Dear attendees, you're also unmuted. You can ask your questions via microphone if you want to. But I also see that Kirill and Pavel, we have still some questions unanswered in the chat box. First one, is there any simulator-based session?
Well, I'm not sure that I'm getting this question right. So if you're asking about some tool which is available for everyone to send GTP packets, I think it is not there. So there is some open source tools, but not many about GTP.
All right. The second question is, if an attacker hacks the ongoing session of the existing subscriber, GTP can detect a change of IME PEI to block the session. Can GTP do that?
Well, you know that IMEI is not mandatory in mobile networks. So even in home mobile network, IMEI may be not requested at all. So it is not something really necessary to make the mobile network work. And in GTP protocol as well, IMEI is just optional field, which may be not filled at all. So well, you can try to block based on that, but in some cases, it is legal that there will be no IMEI, so you will not be able to block anything based on that.
All right. The third question is, PFCP is used in 4G and 5G. Do you plan to talk about threats in CUPS architecture?
We also have experience in that. Maybe it's topic for other webinar. It's not planned for now. So yes, we have some experience on that. So, and there is some vulnerabilities related to that.
All right. The next one is there any GTP certification or telecom security related certification?
Good question. Well, it's so it's dependent on what you are trying to achieve by this certification, because certification is more about some compliance to some regulatory, but in reality it is not very good related to malefactor possibilities. So even if you will have some GTP certification, will have some telco security certificates, it doesn't mean that your network is protected. So maybe I don't know anything about GTP certification, so I never meet it in real life. So I'm not sure that it is present, but I'm sure that it will not protect your network.
Okay, thank you, Pavel. And one more question from Rashad. We know in SS7 we route traffic to firewall from STP. how we should integrate GTP traffic in a similar way?
Yes, it's very good question, because it's not like that, because in SS7 we have STP, in diameter we have DA, and you have entrance point which you can so you can easily use for rerouting traffic and deploy your firewall. For GTP, as GTP protocol based on IP, so the deployment of GTP firewall should looks more like deployment of usual IP firewall. So you need to deploy it on the edge between GRX network, so roaming network, and your network. So somewhere on the edge, you should deploy this GTP firewall. So like usual IP firewall.
All right, and I got also in closed box some questions. Pavel, you mentioned you have conducted more than 100 audits in the previous 12 months. Does this focus only on GTP assessment, or the scope include other domains?
A good question. It's about all domains we have. So we test the networks, not only GTP protocols, not only S7 protocols. We usually test network, so whole network security. So we test in RAN, GTP, SS7, Signal, and VoLTE. So it's about all of them.
All right. One more question. I think it's more related to Kirill. Does this firewall of yours only protect the roaming interface?
Oh, well, first of all, in general, let's say our TSG platform, right, which includes firewall and IDS modules, right, it can be deployed in any network segment regarding the required traffic and traffic policy. So the most obvious, of course, we talk about the roaming interfaces. So we talk about the interconnection between the operators via IPX, or we talk about the national interconnections, right? So in some cases, the firewall can be located on the border between the national interconnections. But there might be also some cases when there are some merges coming between the operators, and it's not they're not, let's say, fully completed the migration, right? And in this case, between them, there should also be some kind of, let's say, security segment that protects from the messages coming from one network to another. And there might be also, we can right, we can consider also the deployments that can be based between the network evolved packet network and 5G infrastructure on this border.
Mm-hmm. Okay, Kirill, I think this is also related to you, to your part of your speech. You mentioned that firewall has IDS module. What is it used for?
Oh, well, it's quite an important part, right? So when we talk about the firewall, it's just about the policing, right? It's about the policing that you have told, or let's say programmed your firewall to work with. But again, we can never be sure that all the traffic, right, all the traffic will flow through the firewall, and there will be no configuration glitch, etc. So in this case, when IDS actually absorbs all the information, it will notify about the occurrence of events where the traffic is actually bypassing the firewall, and the attacks are actually consistent in this, right? And speaking about the integration with some SOC departments, etc., they are very interested in the monitoring of the let's say network security posture, and for them it's quite important to get this information about the incoming traffic, the correlations of the attacks, right, happening into the network, so we can prevent, let's say, further disaster by, let's say, flowing this kind of traffic data to the SIM system to prevent, let's say, further exploitation of the network, so that the SOC guys can prevent bigger damages than what's happened by, for example, information disclosure.
All right, and we have, I think, 2 last questions, and the rest we will spare answer for via our channels, but I suggest to wrap up and answer 2 latest questions. What is the most frequent attack you have observed in live network for GTP? Was it DOS, interception, or fraud?
Well, I think the kind of attack which we see usually it's more about information disclosure, so and some scanning, so attackers trying to just investigate in the network and to obtain some information, because it's the most stealth kind of attacks. Yes, that's the usual one.
Okay, thank you, Pavel. And the last question, is the repository to get all the CVEs related to GTP?
Well, you know that mobile networks, they are quite closed, and moreover, I would say that they are living in some separate world, so it's not related to usual IP stuff. So usually you will not able to find any CVEs related to some telco infrastructure, some telco protocols like SSM diameter. Well, there is some CVE related to GTP, to diameter. I don't remember about SysOn, but there is. But I never seen any repository where they are collected all of them in one place. Nothing like that.
All right. For the rest of the questions, dear participants, we will provide the answers via our channel, via social networks, and via mail. We will share all the presentation and the video recording uploaded on YouTube. We would like to thank you all for coming here, for staying with us, asking really interesting questions. You made this session very informative and insightful. And I would like to thank our speakers, Pavel and Kirill. Pavel and Kirill, if you have something to say before we finish, please do.
Thank you. Thank you all for attending.
Thank you, guys.
Let's keep this
thank you.
more and more.
Thank you, everyone. Keep in touch. Bye-bye. Thank you so much.
Bye-bye.